Back, problem 3, section 4.1. The area A of the region S that lies under the graph of a continuous function is the limit of the sum of the areas of approximating rectangles. Okay? They are using limit n approaching infinity of Rn. Rn means you are using right end point of your subinterval for the height. So this is same as limit n approaching infinity f of x1 delta x plus f of x2 delta x, so on. What is delta x? Delta x is the width of each sub-rectangle, of each rectangle that you draw under the graph. Consider the function fx equals x times cosine x. My interval is from 0 to pi over 2. Use the above definition. Determine which of these expressions represent area under the graph of f as a limit. Okay, this is a good example. So, my function is x times cosine x. The interval is 0 to pi over 2. Okay, that's what I'm told. So, what is the total length of the interval? It is pi over 2 minus 0. Total length is pi over 2. If I'm going to draw n rectangles, then the width of each rectangle should be pi over 2 divided by n rectangles. So n pieces. So say this is your interval, you're going to make n cuts. So you want to have pi over 2 divided by n to be the width of each rectangle. Division by n, well, think of it as a fraction, n over 1. Then you see division is nothing but multiplication by the reciprocal, 1 over n. So I get pi over 2n. That is, the width of each rectangle is pi over 2n. Now, we are told Rn, so we need to use the right endpoints. So here is a picture, right? You are from 0 to pi over 2. You want to draw n rectangles. All right. We know that the width of each rectangle is going to be pi over 2n, pi over 2n, pi over 2n, pi over 2n, so on. Okay. Now, what is the first cut point then? It is 0 plus pi over 2n. That is pi over 2n. What is the second cut point? 0 plus 2 times pi over 2n. So 2 pi over 2n. I'm not simplifying, so don't worry about it. What is the third cut point? 0 plus 1, 2, 3 times pi over 2n. And so on. Okay. Fourth cut point, 0 plus 1, 2, 3, 4. 4 times pi over 2n. I hope it's clear. So for my ith rectangle, I'm looking at a cut point here. This will be 0 plus 1, 2, 3, so on. Because it is the ith rectangle, I'm adding pi over 2n I times to 0. So 0 plus anything is itself. So this number is going to be I pi over 2n. Once you know that, well, what is the height? Height is going to be given by my function f. So here, height is going to be f of I pi over 2n. But what does f do? F is x times cosine x. So I pi over 2n replaces x. So f of I pi over 2n is I pi over 2n cosine I pi over 2n. So this is the height for the ith rectangle. So that's what this R mentions, okay? It's very important to remember this is right. So on my subinterval, I'm looking at the rightmost point and using f to find the height of the rectangle. All right. Once I know that, what is the area of this rectangle? Area of the ith rectangle is width, that's what delta x represents, and f of that chosen number on the x-axis. In my case, the chosen number was this, right? So f of our chosen number is all of this. So pi over 2n represents width, and f of my chosen number, I pi over 2n cosine, this represents the height. So all of this together represents area of one rectangle. Well, once I know that, I'm looking for this expression. What is this summation? Summation means you add the area of the first guy, add the area of the second guy, add the area of third guy, and so on. Add all the areas. That's what this summation means. Why am I taking limit? Well, as of now, my curve looks something like that, right? Curve could be something like this, yes. But my rectangles, if they are too fat, then they don't give me a good approximation. So I need to take thinner and thinner rectangles, which means I need many, many more cut points. That's why limit and approaching infinity. So the purpose of this exercise is to figure out, so limit is common to all the expressions, summation is common to all the expressions. All we need is for our problem, which expression represents the inner part, each rectangle. Well, let me look for pi over 2n. That's these guys. These three guys have pi over 2n. And then I'm looking for I pi over 2n and cosine. So among these three, I pi is here and cosine of I pi is here. So B is my answer. All right. We are done. Until the next problem.